Hello and welcome to Benefit News. You're here with me, Marilyn Gore, and this is the Benefit News podcast. We're talking carbon credits with Siddharth. Siddharth Dabhi here has been with the Center for Grower-Centric Eco-Value Mechanisms. He's been researching carbon credits and carbon markets for 12 years. So we're talking right now about how farming has to do with climate change, carbon credits. Last time we were talking about the methods in agriculture that can affect this. So today we're talking about how does one of these projects come to be?
Carbon projects in agriculture are a bit complex to do. Okay, so there is, on the one side we have smallholder farmers. That's the reality of Indian agriculture, right? So we are talking about farmers with an average land holding of one or 2 acres only, right? Now, to be able to do a regenerative agriculture project, you basically need at least 10,000 hectares to make the project viable. When I say 10,000 hectares, I mean approximately close to 12,000 farmers you need to aggregate. Okay. So that economically speaking, the project is viable enough to do. Now, in this process, there are different players who need to get together to make this entire project a reality.
Right.
So the first player that you need is what we call in the carbon lingo a project developer or a carbon project developer.
So this is the people or organization that will go to the farmers, right?
Yes. These are private entities and they have the sort of knowledge and the skill to do 2 things. One is they understand how carbon registries work. So they know the scientific methodologies through which that carbon reduction and removal is calculated, right? And they know the buyers in the global market who will buy the carbon credit, right? So these folks basically reach out to farmers.
Okay.
How do they reach out to farmers, right? You can't simply just go to a farm, tell a farmer
I'm assuming there are NGOs that work at the ground, at the grassroots level.
Exactly. So they reach out to the grassroots NGOs. They reach out to farmer producer organizations.
Okay. These are what are called FPOs?
FPOs,
Okay.
yes. So these are the aggregating units, right? So they reach out to them. They explain to the NGO that, okay, we are doing this sort of a carbon project and you are directly working with farmers, helping them do good practices in agriculture. Let's get them on a project. So this is how the farmers are chosen, right?
Okay.
And then there is a whole process of onboarding farmers.
How does that work?
Basically, you need to kind of work with the farmers, understand what agriculture practices are they doing, and then, map the land parcels that they are working on and things like that. And that's how you onboard farmers. So that's one thing. And
So
then you need to write
measurements involved.
Yes,
here, right?
There's a lot of measurement. You need to measure the land parcel. You need to measure the activities, the practices that they are doing. And through those practice mapping, you get to project how many emissions will you be reducing.
Okay. Does the fertility of the soil and the crops that are already being grown, they also matter?
Yes. So we need to see what sort of cropping pattern, you need to see whether they are doing multi-cropping, crop rotation, residue management, things like that. Different practices are kind of calculated and each practices affects how the emission is reduced or removed, right? And then the soil is basically tested in labs to see how is the soil organic carbon increasing and so on and so forth, right? So that is one part. So that's the role of the project developers. They do all the measurements.
Okay.
And they write what we call is a project design document.
So this is like a proposal.
Sort of like a whole design of the project. This design document is submitted to what we call as a carbon registry. A carbon registry is basically a registry that keeps
Is that your
a
APMC
record.
Is that what you're talking
Not
about?
the APMC, but it's more like a sort of a SEBI in some sense of the carbon markets, right? So they keep the know-how of all the projects that are happening around the globe. They set the standards through which the measurements are done, things like that, right? So your document goes there. Then they go through your document. They have a set of what we call as validators.
Okay.
These validators come to the ground, see or meet your farmers, and then they validate. Yes, actually they are doing a project. It's not just some paperwork, right? Once your project is validated, your project gets registered on the registry. Okay. Now, once it is registered, then there is an entire process of monitoring period, right? So you take an entire year to monitor what the farmers are doing. And then you cross-check it against the baseline. that you have set up, right? So
Okay.
in the baseline, the farmers were not doing regenerative or natural farming practices. Now in this 1 year of monitoring, they are doing. Hence, you counter check what is the emission reduction, what is the emission removal, right? So
Okay.
then the project developer, based on various methods. So the methods are like, they do crop modeling.
Okay.
They do projections of the emission reduction
So a
based
lot of
on
statistics.
Yes, it's a lot of statistics, it's a lot of computer modeling. Then you also use a lot of satellite data to see whether those practices were actually happening on the ground or not. So it's a triangulation of data coming from multiple sources that creates the basis of the actual emission reduction calculation that you do, right?
Okay.
Once that is done, that is again submitted to the registry. Now the registry will send an auditor, just like a regular accounting process. The auditors come to your company. Similarly, your auditors come to the ground, and they will go through all the submissions that the project developer has made in terms of emission reduction. They'll again go to the farmers, speak to them, validate that actually these practices are happening on ground, so on and so forth, right? And that is how they will say that, okay, let's say, for example, your project developer has said that in this 1 year, 10,000 tons of carbon dioxide was reduced, for instance. And the validator will come cross-check. Maybe the validator will say, yes, 10,000 were actually reduced. Probably they might have some difference in opinion and they would say, okay, not 10,000, but 9,000. Now, whatever the auditor finally tells the registry, that is how the registry will again go through everything and finally issue you carbon credits.
So whose decision is final here?
The carbon registry.
Okay.
Yes.
All right. So it's not that the validator has a final call on this. The auditor has a final call. Nothing like that.
No.
Okay.
So the registry will finally issue you carbon credits, which come to the project developer. Then the project developer goes out into the market and tries to sell. Again, there are multiple channels of selling. You can directly sell to a big MNC like the Google or the Volkswagens and so on and so forth. Or you have market aggregators who aggregate carbon credits, you sell to them. Or there are carbon exchanges, which is like a spot market, right? There are multiple channels. And then you sell. Once the project developer receives all the money from selling that bunch of carbon credits, then they kind of cut out their own costs, their consultancy costs, their HR costs, whatever, so on and so forth. And then whatever is remaining now depends on the contract, goes to the farmers. Some share might go to the FPO or the NGO that was kind of facilitating all the process. So this is what sort of a typical carbon project looks like in agriculture.
You said that the money that comes in from these carbon credits is then split between the farmers and the FPOs and then the project developer also. So is this like a percentage based thing, or how does this work?
No, that's a very interesting question, Marilyn. It is not a set percentage, right? So it is something you negotiate. And that is the key, I think,
So
for
if your
farmers.
farmer doesn't know what's going on, then they're not going to get a good deal out of this.
Exactly. You have hit the nail. So that's the point. That one is farmers need to know on the ground. Not just farmers, the FPOs need to know what is a carbon project, how is it all done. The NGOs on the ground need to know what is a carbon. And they need to understand the intricacies of the market dealing so that they can negotiate on behalf of the farmers for a better deal.
Why would a farmer want to pull out of something like this?
Because let's say we are smallholder farmers, right? Now, let's say you have a sudden drought that has hit. Now, then next year for the farmer to expect them to work on very low or zero pesticides might be difficult because they need to again bounce back. This is not the case for large farmers who have big land. They can take those shocks of nature. Smallholder. And the last aspect that really needs to be negotiated is data sharing and data protection. Because here we are collecting a lot of data from farmers. We are collecting personal data, their names, their bank details because the money has to be transferred to them, their land details because we map the land parcel and we check in whose name the land is, right? We are mapping all the practices, the agriculture practices they're doing. We are mapping the inputs they're putting. We are mapping the emission reductions they're doing. So it's a lot of data which can be sort of sold for commercial purposes by other entities without the farmer knowing.
That is scary.
Right? So we need strong data protection over there. Secondly, we need data sharing. So, for example, a lot of your data is being used and then it will be creating the carbon credit. The farmer should know. So, I'll give you an example. Let's say you have collected all this data of the good practices, right? That they did ABCD activities on the farm, hence so much emission was reduced. If this data goes back to the farmer, then probably in future the farmer can use this same data even for, let's say, an organic certification, can also use this data for a regenerative agriculture certification.
What do these certifications do for them?
It gives them a better price for their produce.
Of course.
Now, in general practice, if I want to go for an organic certification, it is going to cost the farmer, right? But here, the data is already there. So if we make this data accessible to them, then probably for free or maybe a very minimal cost, they will be able to get access to other certifications.
Okay.
So that data sharing has to be in place. So these things need to be negotiated.
Also, you said that once they've decided, the powers that be have decided what the costs are going to be, what the payout is going to be, does that trickle down? Does that knowledge or information trickle down to the farmers?
Again, great question. To trickle down the knowledge, generally it doesn't happen. But to trickle down the knowledge, basically, carbon registries have a system called that you have to do two things.
Okay.
Local stakeholder consultations and free prior informed consent. These are two important pillars which are generally not taken.
Consent would mean a lot of work for everybody else.
Exactly. So a lot of people don't stick to it in word and spirit. But that is something that we need to strongly advocate for. That one, the farmer knows every detail of what the project is all about, what they're entering into. That is the free prior informed consent. And only once they agree to it, they are onboarded. Very important. And local stakeholder consultations where repeated, it can't be a one-time event that, you hold a meeting and you tell the farmers and things are over. At repeated intervals, you have to keep meeting your farmers.
Got so many evaluations going on all the time.
So farmers constantly need to be told what's happening, what's the progress of the project. If it is stuck, where is it stuck? What's happening? Even the details of, how much carbon credit is accrued from their farm, being sold at what price. All of these details need to be shared and made transparent. Only then, you do a good project. Because what we need to understand is that this is not just any other project. Carbon projects of any type are environmental projects.
Of course.
And climate change is a public issue. Hence, it's a public good. And public good has to have complete accountability and transparency.
I agree with that, but I'm also curious as to how curious are your farmers, the farmers that you work with?
They are curious.
Do you have any stories?
Yes, they are very curious. The levels of curiosity kind of vary depending on their awareness. But for example, if you go to Gujarat in Surendranagar side, farmers are very commercial minded. They understand the language of money. So they will immediately ask you very pointed question. No, who are you going to sell? What is the price right now? How much money will I get? They are curious. There are differences. So you generally, the men will ask you more questions around the money side of it. When we talk to women farmers, they generally connect it with the larger climate change issues, the environmental issues that they are facing, and they see how is it going to help me? Is it going to mean better nutritious crops or better food or more quantity yields for food? These are the kind of questions they ask.
Women also do a lot more of the, let's say, smaller tasks in agriculture, right?
Yes.
So does this increase their workload?
Yes. So now,
I would assume that is also why they'd be interested in these things.
Yes. So in regenerative agriculture or natural farming, generally it has been observed that both for men and women, the amount of work on the farm increases.
Okay.
Why? Because here you are, like, for example, here you are not doing blanket spraying of a pesticide, right? Here you have to literally observe your crop and do things according to your crop and prepare natural. You have to prepare natural farm-based manure or farm-based pesticides and things like. So it's a lot of work. So proportionately, the work obviously increases a lot for women. So that is the challenge that we are trying to tackle, that how can we sort of reduce the burden? And then that's a thing of research and, for the future.
No, but right now, the way it stands, do you guys do anything with that? Does your organization have like a tie-up with somebody else? who's
Not
looking into
yet.
that?
Not yet. We are
Okay.
still kind of scouting for people who can help us through.
All right.
Yeah.
Hi, we're back with Siddharth from the Center for Grower-Centric Eco-Value Mechanisms. And we're talking about carbon credits and how farming and sustainable farming, regenerative farming, you mentioned there's a difference between those.
There are some differences, but for now, let's all call
Alright.
them under the same umbrella.
Okay. So we've been talking about how farmers can do their bit for, how they can benefit from doing their bit for carbon credits.
Yeah.
Okay. Something interesting I read recently, I'm assuming it comes under what you're doing, is that Google has tied up with an Indian agri-tech business about something about biochar. What was it? Do you remember?
Yeah. So basically, Google is going to buy credits, carbon credits, which are sort of calculated from production of biochar.
Okay, so which means we will now go to what is biochar.
Yes, we'll go.
I know we discussed this, I think, in the first episode, was it?
Yes, we did briefly talk about biochar, but so what is biochar? So there are two parts: bio and char. The bio comes from the biomass.
Organic
the char
compounds.
is the charring process. Where you burn it in a particular way. To put it very simply, it is biomass that is burnt with very low oxygen. So that kind of creates this product which is called biochar. When it is burnt with high oxygen, you get charcoal. Okay, so that's different. Biochar and charcoal are different.
Yeah.
But let me take you to some bits of history, which is very interesting.
All right.
So about 2,500 years ago, in the Amazon basin, the Indian communities living there, not our Indian, the American Indians living in Amazon.
First Nation people.
Yes. So what they started doing is they were burning their biomass, okay, and mixing it in the soil along with other things like, let's say, earthen pots, bones of dead animals, maybe even human beings. And, they were kind of putting them in their fields.
Okay.
Okay. And this process started about 2,700 years ago. What it resulted is that it kind of made the soil very fertile and almost black in color over all these years.
Okay.
And that is popularly called as terra preta.
Terra preta.
Yes.
Terra being earth.
Preta being the char.
Okay.
Right? So terra preta is what it became to be known over there. And then one fine day, some scientist kind of discovered this thing in Amazon. He was very surprised. Like, what is this? Because in tropical and subtropical zones, you can't find soil that is so black and so fertile. Right? The soil was black and it was very, very fertile.
Okay.
Right? Because what happened in tropical and subtropical areas, because of the heat and immense sun, the soil kind of becomes hard, and you will see that soil texture being either red or yellow kind of thing. Right? So this is a technique that people over there realize how to make their soil fertile. And then this as a system was not adopted worldwide, as it were. Of course, in Africa also you had people practicing biochar making. Even in India, historically, we have been making biochar in places.
On purpose, or was it? Do you think
On
it was
purpose.
accidental at some point?
The discovery could have been accidental. So, for example, in India, if we take slash and burn agriculture, which is practiced in Northeast and a lot of tribal areas in Odisha and other places, or which is popularly also called as jhum cultivation. It's something similar, right? You slash your trees and the forest area, burn it, controlled burning, and that creates a char, makes the soil more fertile, right? So so we have been doing something similar. And now in the context of climate change, suddenly we realize the potential of it.
1,000 years seems like a very long time for us, but if you're looking at a geological cycle, then it's not really that long. But you're saying that is the best we have right now?
Yes, that is kind of 1,000 years in the sense that it could be even longer than that, right? If the biochar is not disturbed, it could be longer. But 1,000 is the sort of the market kind of language of saying that this is there for really a very long time. Yeah.
So normal, let's not say because biochar, if I remember what you explained correctly, is when you're burning carbon-based compounds at low temperatures for a
high temperatures and low oxygen.
Yes.
Yes.
So basically you're holding in the carbon.
Yes.
All right. So when you're talking about normal, we're burning something quickly, it is
Charcoal.
charcoal, yes, but charcoal, how, when you say high temperatures, what do you mean by that?
300 to 500 degrees
And how much is a normal fire?
I mean, that
Like
is also...
if somebody were to just burn a field.
So normal temperatures can also go up to 300 and 500, but there is plenty of oxygen that is available. Here I am saying high temperature within the bracket of 300 to 500 and low oxygen.
How do you control that?
So you have machines for doing
Okay.
it. So there are different ways in which biochar can be produced. Each have different efficiencies.
Okay.
Okay. So the simplest way is a very indigenous method. You dig a pit, you put your biomass, you cover up the pit, and hence there is low oxygen, and you burn the biomass inside that
That sounds
pit.
like a cooking technique.
Sort of, but yeah, this is for biochar. Yeah. So that is the indigenous sort of low tech way of doing things. Slightly better technique is that you create a kiln.
Okay.
Okay. In the kiln, you kind of burn the biomass at low oxygen. But again, here the challenge is of maintaining the temperatures because it's a kiln. You can't control it so well. So that is why there are industrial sized machinery now to produce biochar at a greater scale, where you can control your temperature, you can control the oxygen that you are giving and things like that.
What is the volume we're talking about here? Like, I would assume it would take a lot of organic matter to create a smaller quantity of biochar.
So basically...
So is there a ratio here?
Yeah. So let's take... you are taking, let's say, 100 kilograms of biomass, for instance, and now trying to convert it into biochar. Basically, you will get about 40%, that is about 40 kilograms as biochar. Remaining all 60% goes off.
Goes off as
Waste.
like in what form?
Different kinds of waste. It will create solid waste out of it, and also a lot is burnt off in terms of the gases that go off.
When you say solid waste, this is landfill material, or can it be used in the fields again? How does it work?
This basically is not something that you can use it on the agricultural field, so you'll have to kind of but it is decomposable, so that's fine.
Of course. All right. How does a farmer get into this?
So India, because we are so agriculture dependent, produces close to 500 metric tons of agricultural waste
500 metric. Is that per year?
per year.
Wow.
Yeah, because from different crops like wheat, rice, sugarcane, oilseeds,
And you're
other
talking
things.
about from the field itself.
Yeah, from the field.
You're not talking about processing.
No, I'm talking about the field.
Wow.
Yeah.
Okay. Huh.
So that is the amount of biomass waste that is generated year on year. Now, of course, this biomass that is there has multiple uses. I'm not saying everything just goes to the landfill.
Of course.
Right? So a lot of waste is used for building thatches, on the roofs in villages. Some of the waste is used as fodder. Some waste is kind of used for other packaging material. If you see a lot of new companies are coming up with startups that you use it for other products, right?
I think especially sugarcane and corn, there's a lot of work going on there.
There is something in industries now, they are using something called briquettes, so that's all of the multiple uses of biomass. Biochar is one more addition of use. Now the difference with other uses is that other uses creates different products which are used, like I said, but biochar can be used as a soil amendment. It's like a manure for the soil, right? Particularly in soils in our kind of conditions, subtropical, tropical, which have low fertility and where the soil organic carbon
Where your
is
weather is extremely hot also, right?
Yeah. So that is where adding biochar to your soil as an amendment really helps to make your soil more fertile.
Yeah, you mentioned that when you have higher carbon content in your soil, it gets springier.
Yes. So that is the whole sort of use, and that is why biochar becomes important.
So when you say it's an amendment, is that, I might be wrong here. So does that mean that if I'm putting, say, extra fertilizer, natural fertilizer, whatever, that the soil will absorb it better?
Yes. So it kind of works slightly differently in the sense that so when you apply biochar to your soil, So if you are just looking for good growth of your crops and fertility of your soil, then you apply biochar at the topsoil level, at the root level. Okay. If you are purely looking at biochar from a soil organic point of view, then you apply your soil biochar slightly deeper in the soil, not at the topsoil level, deeper.
So would this be different for farmers doing crops versus trees? I mean, plants versus trees?
No, it will more or less be the same.
Quantity would be different, I assume.
Yeah, the quantities will be different.
But the depths?
The depths will also be the same, because even if with trees, if you're just looking at tree growth and improving you just put it at the topsoil level, right?
Okay.
But like I said, if you're purely looking at, you take a patch of soil and you want to,
regenerate it for the next few years,
let's say very degraded patch of soil, let's say where mining was taking place. Now mining really makes the soil almost useless and barren, right? Now if I want to regenerate so degraded soil, I just dump biochar there.
And how long does it take after that?
We don't have really concrete studies to say that it will take so and so years. It takes a few years, but definitely because the property of biochar is this, that the nutrients kind of circle around it and come, and it kind of
like
sticks
a magnet.
on. Yeah, kind of a magnet.
Okay, so that is helpful.
Yeah, another use of biochar that we are seeing, apart from agriculture as a soil amendment, is a lot of places we have invasive species of plants, right? So, for example, in vast areas of Gujarat and Rajasthan, we see Prosopis juliflora, which we commonly call Gando bawal or Vilaiti babul.
Also, these
Lantana camera.
Lantana is all over the place.
Yes. Now, these are invasive species. They're spread like over millions of hectares, right? Now,
Gulmohar also, right?
Sorry?
The Gulmohar comes from, I think, South America. Or South Africa,
still it's not that invasive. But particularly if you take the example of Lantana camera Prosopis, there is a very concrete examples of what invasive species does to the landscape, right? So there are experiments where people are trying to remove Prosopis juliflora, and that biomass of Prosopis juliflora is used to produce biochar.
All right.
So there are these kind of uses also.
This again goes back historically to the colonial era. These I think these are planted because they needed less water.
Yeah. So Prosopis came as a measure to stop desertification, right?
So good intentions.
Yeah, but nobody understood what will be the 100-year down consequences of having. Lantana camera came because it was an ornamental plant which the British loved. So, but yeah, turned invasive.
As they say, go to hell.
Yes.
Yeah. So biochar. You said industrial production. Can a small farmer also do this? Like, how common is this? Do small farmers do it? Yeah. Suppose I want to do this, say, as a hobby gardener. Does it make sense to do it on a small patch of land?
Maybe. So, as a hobby gardener, what you can do is buy biochar from somewhere and apply it to your garden. That's what you can do. But for smallholder farmers, again, the thing is that you first need to aggregate them. Right? Because collecting biomass from so many small fields is a challenge. It means labor, it means transportation. And all of this means cost. Right?
Not just cost, but since we're talking about reducing carbon emissions.
Even that is another form of emission that is there, right?
So if you're transporting this stuff, does that balance out?
Yeah, so when you calculate the carbon credits, you do a complete life cycle analysis of how the biochar was produced, which has to include the transportation cost or any other sort of fossil fuel using machinery to actually get the biomass. So for example, let's say you have a standing crop, right? Once you have harvested, how was the stubble removed? Was it removed using a machine? How is that machine powered? So let's say if it's powered by diesel or petrol, I need to factor that in.
And would different crop remnants require different amounts of labor? Like I would assume that, I don't know, say sugarcane stubble, for instance, would be harder to remove than
Yeah, so for all of these, generally we have machinery.
Okay.
We have machinery.
So is it the same? When you're talking about from an emissions level, if the same kind of machinery, does it affect how long they have to work on?
It wouldn't be too much of a difference.
So eventually it's about the same.
Yeah.
So does it make sense for us to go back to manual labor for this?
It's not possible. because you see, agriculture again is a business, right?
Yeah.
So the amount of time I take to remove that stubble of a previous crop and then to prepare field for a new crop doesn't make so. So why are Punjab farmers burning off
crop.
the stuff? Because they want to immediately prepare the land for the next crop.
So the same thing, if there was a way to do it with low oxygen, the same thing could have been done.
So that is why you see biochar programs are coming up in Punjab, Haryana with the rice stubble. So they are trying to say that instead of burning, let's try to go in for biochar so that it gets you good money. And so basically a biochar carbon credit sells in the market anywhere between $100 to all the way up to $200-250.
When you say one carbon credit, how much carbon are we talking here?
We are talking about 3 to 4 tons of carbon.
That is quite a lot.
Yes.
And what is the market like in India? Carbon credits?
So India doesn't have a market yet, right? So everything is sold in the international carbon. So that is why you have MNCs from the global north, basically the US, Europe, Japan, who are buying carbon credits. So that is why, for example, Google doing this deal. It's basically Google USA that is doing the deal.
Thank you, Siddharth, for joining us again. We've learned a lot. If you liked what we just spoke about, if you have any questions, leave us comments. Like what we're doing, share it among your friends, share it among people who might learn something from this. And we'll see him again next time. Thanks for joining us. I'm Marilyn Gore.